Today's essential question, which is number 2 out of 4 for this concept: what is the history of Earth's atmosphere? Please take this down on the top of your notes under essential question. The topic is still the development of Earth. Once you have the essential question taken down, we can move on to our first definitions today. Atmosphere. Atmosphere, as a simple definition, the layers of gases that surround a planet. Not all planets have an atmosphere, but if there is a layer of gas that surrounds a planet, we call that an atmosphere. For example, Earth is surrounded by a blanket of gases. The air we breathe is part of the atmosphere. Now, an atmosphere can have many, many layers, and the different types of gases and different conditions and different layers can obviously be incredibly different. However, they're still layers of gases. Next definition: solar wind. Solar wind can be a difficult idea to understand, but a solar wind is a continuous stream of charged particles that are emitted by a star like our sun, which flows outward from the sun in all directions into the rest of the solar system. Now, what we know about the solar wind is that it is made up mostly of protons and electrons from hydrogen atoms, because most of our sun is hydrogen. So it's the protons and electrons from those hydrogen atoms. Now, Earth happens to be protected largely from solar winds and their negative effects by both our atmosphere and our magnetic field. Speaking of which, our next definition is magnetic field. Magnetic field is a set of lines that defines the motion of charged particles near a magnet. Now, why do we call these lines? Because magnetic fields surround all magnets. All magnets. And when we represent magnetic fields, we usually represent them as a collection of vector arrows. And those vectors indicate the direction and the size of that particular magnetic field. Now, if you'll remember, Earth's core has a solid, rotating iron portion, which acts as a magnet. Well, let's get into the lecture. Our first left-hand column today, Earth's early atmosphere. Earth's early atmosphere. So we know that an atmosphere like ours is comprised of gases that surround the surface of Earth. The composition of gases in the atmosphere has changed quite a bit through time. The earliest atmosphere was composed primarily of hydrogen and helium gases. These gases were too light for the planet to retain. Many scientists think that solar wind, which remember are charged particles from the surface of our sun, scientists think that solar wind carried that young, light atmosphere away. Today, solar winds are deflected from our planet by Earth's magnetic field, but that early planet did not have this protection. Earth's magnetic field did not form until Earth's core formed. As a result, gaseous hydrogen and helium in that original atmosphere were lost to outer space and remain relatively rare on Earth today. Many scientists propose that the Earth's first atmosphere developed from the release of gases from volcanoes into the atmosphere. This early atmosphere would have contained mostly hydrogen and large amounts of water vapor, carbon dioxide, and hydrogen sulfide. It would also have contained much smaller amounts of nitrogen, carbon monoxide, methane, and some other gases. It is also thought that this early atmosphere was blown off from the planet not by solar wind, but by a catastrophic impact with a huge with a huge object the size of Mars, that as a result of this massive impact, that early atmosphere was again thrown off into space, and this would have happened around 4.5 billion years ago. Now, a lot, maybe most, but a lot of that matter later condensed, forming what we understand to be the moon. But this intense energy released by that impact left much, if not all, the Earth in a molten state. Then, about 4 billion years ago, so about half a billion years later, the composition of the atmosphere changed once again. The planet was still in the process of cooling. Volcanic activity at the planet's surface expelled a variety of gases into the atmosphere, primarily water vapor, carbon dioxide, and hydrogen sulfide. Now, there were also trace amounts of nitrogen, carbon monoxide, methane, and ammonia, but primarily water vapor, carbon dioxide, and hydrogen sulfide. Now, these gases reacted with minerals that were found on land and dissolved in the ocean. These gases, the gases that did not react, would begin to accumulate and form Earth's second atmosphere. Now, our sun's light, solar energy, broke down the ammonia that was being released from volcanoes. And the nitrogen that was released from this process, because ammonia contains nitrogen, the nitrogen that was released from this process slowly increased in the atmosphere until you reach the largely 80% nitrogen in our atmosphere today. So at this point, you should be able to answer today's essential question: what is the history of Earth's atmosphere? At this time, please write your answer to today's essential question in the summary box on your notes.